are working on lesson 3 of chapter 7. So you need to go to your books to lesson 7.3, and this will be page 315. Okay, page 315. Pause the video at any point whenever you need it to catch up or to listen to something again. We're going to start off by writing the objective. This lesson, and the objective of this lesson is we will multiply fractions and whole numbers. So that is the objective of what we're going to do. How can you find the product of a fraction and a whole number without using a model? So basically, we will now be using or multiplying without the models. Actually, we're going to have a little bit of both. So we will be able to see it in the model, and we will be able to see it without using the model. Okay, let's go ahead and get started with unlock the problem. So we have here, Charlene has 5 1-pound bags of sand, each a different color. For an art project, she will use 3/8 pound of each bag of sand to create a colorful sand art jar. How much sand will be in Charlene's sand art jar? So, I don't know if you've seen a sand art jar, but there are these beautiful decorations. So you have different layers of different colors, and it just looks beautiful. Okay, so the question here is, how much sand will be in Charlene's sand art jar? I read that backwards. So remember, when we have a word problem, we want to circle the important information. So we know that she has 1-pound bags of sand, each a different color. She will use 3/8, right? 3/8 of each bag, and then she has the total of let's see, 3/8, and she has of each color. And the question is, how much sand will be in Charlene's sand art jar? So how much sand is in each bag? Okay, that's our first question. And so we know that it says that Charlene has 5. Okay, so if you see here, this is another important information. Now each bag has 1 pound. And the question is, will Charlene use all of the sand in each bag? No, right? It says that she will only use 3/8 of each bag. And she has 5 of them. So we're going to just quickly create a model so that we can picture this. Okay, so here is our model. We're going to do the model section first, and then we're going to do it without the model. So here it says 5 times, and then we have a model. The reason why we have 5 is because it says that Charlene has 5 1-pound bags. This model represents 1-pound bag. Okay, so this is 1-pound bag. And we have 5 of those. Each bag, we're only going to be using 3/8 of the bag, right? That's why our model of 1 bag is divided into 8s. 1, 2, 3, 4, 5, 6, 7, 8. And we're only using 3 of those 8s. And so we have shaded in 3. 1, 2, 3. We want to know how much sand will be in Charlene's sand. So once we combined all 3/8 from the 5 bags, we want to know how much sand will be filled. So what we're going to do is actually draw out the 5 bags. Here we have 1, 2, 3, 4, 5. And remember that we're using 3/8 of each bag. So I'm going to go ahead and shade in the 3/8. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I did 3/8 on each. Okay? 3 out of 8 parts. I only shaded 3. But now what we're going to do is rearrange the shaded pieces to fill as many holes as possible. In other words, I'm going to combine all the shaded parts to find out how much sand is in the jar. So if I do that, I'm going to just add these here, um, shade them in, but in using only one model. So that's 1, 2, 3. Now I'm going to add the next one, which I shaded in blue, which now I don't have the color for some reason. Okay, blue. Okay, 1, 2, 3. I was trying to do blue. 1, 2, 3. Okay. Okay, now let's add the next one, another 3. That's 1, 2, 3. Now let's add the fourth bag, which I did light green. 1, 2, 3. And now let's add the last one, which I did light pink. Those 3. 1, 2, 3. Okay, so basically I rearranged it, okay, to fill as many as holes as possible. And I have one hole, right? Because there's one here, it's completely filled. Okay, and then I have 1, 2, 3, 4, 5, 6, 7. 7 out of 8, so 7/8. So that means that um, here my answer was one hole and 7/8. Okay, because my second hole was not filled completely. So that means that it was 7/8. Okay, we just did this as a model. Now we're going to see how we do this without the model. Here we have, for example, it says write the expression to represent the problem. So we have 5 times 3/8, and we're multiplying because each bag we only took 3/8, and we have 5 bags. So I need to find 5 groups of 3/8 pieces. Then we will multiply the number of 8 size pieces in each hole by 5. Then write the answer as the total number of 8 size pieces. What does that mean? I'm going to multiply the number of bags because that's basically kind of like what we did, right? We multiplied 5 times by 3 eighths that we had on each. So I'm going to multiply it by 3. And so if you do that, think about it. 5 times 3, we got 15. And those are eighths. We're talking about eighths. So here, even though our answer was 15/8, we need to write it as a whole number or as a mixed number. So I can also do this by dividing 15 divided by 8. Okay, because a fraction, or when you see this, it's all, you can also think about it as division. I'm dividing the numerator by the denominator, and this is another way that you can learn how to convert a fraction greater than 1 to a whole number, to a mixed number. So I think how many times does the 8 fit into the 15? It goes in only one time because 8 times 2 is 16. It goes over. So that means that this will be my whole number. 1 times 8 is 8. And so 15 minus 8 is 7. So my fraction will be 7/8, right? 7/8. So when I change that to a whole number, we get 1 and 7/8. So, and it's the same thing as what we did with the model. So there are 1 7/8 pounds. Okay, if you still don't get it, don't worry. I think you need to hear it. We're going to do it again because it takes several times to to start getting used to it, understanding the concept. So here we have another example. Let's try this one. We have Kristen brought in 4 loaves of sliced bread to make sandwiches for the class picnic. Her classmates used 2/3 of the bread. How many loaves of bread were used? So she brought 4 loaves, right? There's 4 loaves. And then her classmates used 2/3 of the bread. Okay. So we're going to make the model. And in our model, we have 4 loaves of bread. Of course, they're not squared, but we're just making this rectangle represent loaves. Think, I can cut the loaves into thirds and show 2/3 of them being used. So if they only use 2/3, what I'm going to do is that um, each bread, I'm going to cut it into thirds. How do I know how to cut it? Well, look at your fraction. If they ate 2/3, that means that our whole number is cut into thirds, into 3 parts. So I'm going to divide each loaf into thirds. 1, 2. See, I have 1, 2, 3 pieces. And I'm going to do the same to all of the loaves of the bread loaves. If you don't know what's a loaf, it means bread. Es una barra de pan. Okay, loaves of bread. And now we're going to shade. Okay, we're going to shade. See, use yellow. Okay, we're going to shade 2 out of 3. So out of these 3 pieces, I'm only shading 2. Okay, and I do that to all of the bread, each loaf of bread. Okay, and there I'm showing 2/3 on each. And now to find out how much that is, I want to know how much is the total of the shaded areas. But I want to I want to see it with whole numbers. Okay, because I could totally see that I have 1, 2, 3, 4, 5, 6, 7, 8 pieces, and they're cut in thirds. So I have 8/3. But I want to know how many whole loaves that equals to. So I'm going to again divide this into thirds. But now I'm going to put together the pieces so I can see how many whole numbers I have. So I start off by shading the first loaf, the two loaves of the first loaf. Okay, that's done. And then now let's do the second loaf. Let's add 2 more. So here's 1, 2. Then I go to the third one. I have 2 more. Let's highlight those. And then the last one, 2 more. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8, right? 8/3. That is equal to, so now I count the whole numbers. I have 1, 2, and then this is not a whole because it's only 2 out of the 3 are highlighted. So I'll write this as a fraction. So that means that I have 1, 2, 2 and 2/3 of loaves of bread were used. Now let's look at this as a fraction. So we have 2/3 times 4. That's what we're doing, multiplying 2/3 times 4. We're going to multiply the 2 and the 4 because I have 4 of the 2/3. Okay, and the 3 is in the denominator. 2 times 4 is 8, and that is 8/3. So now we're going to write the answer as a mixed number. So basically, how many times does the 3 fit in the 8? That's like dividing 8 divided by 3. So how many times does the 3 go on the 8? 2, 4, 6. I'm sorry, 3, 6, 9. So I say 2 times. 2 times 3 is 6. Then I subtract. That's 2. So that's 2 and 2/3. So this is my denominator. This is what was left over. And it comes from that. Okay, just so you know where that's coming from. Okay, let's go ahead and now try it again. But we're not going to use a model anymore. Um, and so I feel that the book is kind of missing this part. So I'm going to explain it now. And I want you to get used to this. When it's a whole number, when you have a whole number, okay, remember that any whole number is the same thing as writing. If you want to write it as a fraction, you put it over one. Okay, four ones. Um, so in this case, find the product, write the product in simplest form. So 4 ones times 7 eighths. So when you're multiplying fractions, you're basically just going to multiply the numerator with the numerator and the denominator with the denominator. Again, you multiply the numerator with the numerator, the denominator with the denominator. So we say 4 times 7. What is 4 times 7? That is equal to 28. And then we say 1 times 8. What is 1 times 8? That does not look like a 28. 1 times 8 is equal to 8. Okay, now we want to write this. We want to first, we want to simplify and then write as a mixed number. So you have two options. You can either divide it like 28. How many times is the 8 going to the 28 to find how many whole numbers are in 28 if I'm cutting it in parts of 8. So I could do that. You can, if you write your multiples, 8, 16, 24. So 24 is the closest one. So that means that it goes in 3 times. And I subtract. So 28 minus 24 is 4. So I have 4 left over. I'm not going to write remainder. I'm just going to make it into a fraction. So remember that this is my denominator that I will put here. So that's 3 and 4 eighths. And I can simplify this, right? Because I know that I can divide both the numerator and denominator by 4. So that is going to be equal to 4 divided by 4 is equal to 1. 8 divided by 4 is equal to 2. So that's 3.5. Now let's do it again. I have 5 nines times 12. Remember that any whole number, you can, to make it into a fraction, it goes, uh-oh. Let me see if I can do this. No. There you go. I'm putting it in parentheses because it won't let me make the fraction. But it's the same thing. So we're putting our whole number, rewriting it as a fraction. So remember that you do that by putting it over 1. Okay? By putting it 12 with the denominator of 1. That 12 over 1 is the same as 12. So now I'm going to multiply. And when I multiply, I'm multiplying the numerator with the numerator, the denominator with the denominator. So 5 times 12 is equal to 60. And then 9 times 1 is equal to 9. Now, I'm going to change this to a mixed number. I think it'll make my number easier to work with. So you can think, how many times does a 9 fit into 60? But I think that for some of us, it's easier to make it into a division to figure that out. So I'm going to write 60 divided by 9. How many times does the 9 go into the 60? Well, look at your times tables, right? Or write your multiples to figure that out. 9, 18, add 9, that's 27. Add 9, that's 36. Add 9, that's 45. Add 9, that is 54. And I think that's my last choice because if I add 9, it goes over. It's like 63. So I'm going to stick with 54. And so that means that it was 1, 2, 3, 4, 5, 6. 9 times 6. So 9 times 6 is 54. So now I'm going to subtract. And so when I subtract 60 minus 54, that is equal to 6. Oops, I'm going. So that means that I have the remainder left over 6. And I'm going to put that over. So the denominator is 9 over 9. Now it's easier to simplify the 6 nines because I know that 6, like I can see that the number that is can go evenly in 6 and 9 is 3 because 6 and 9 are multiples of 3. So I'm going to divide by 3 both the numerator and the denominator so that the answer then is 6 divided by 3 equals 2. 9 divided by 3 equals 3. So the answer is 6 and 2/3. I'm going to go ahead and do one more. I'm going to do number 2. And then you can try number 3 and 4 and you'll put your answers on the slide on Pear Deck. So we have here 2/3 times 5. Remember that I'm going to rewrite this as so that my whole number is over 1. Okay, because any whole number with a denominator 1, it's that whole number. Okay, so now when I do that, okay, that is going to be equal to, I'm going to multiply the numerators. Okay, so the top numbers, I multiply them. 2 times 5 is 10. And then 3 times 1 equals 3. So that's 10/3. But I cannot leave it like that. I need to make it into a mixed number. So remember that you can do that by dividing 10 divided by 3. Okay, you can, because that way you're thinking, how many times does a 3 fit into the 10? And then whatever's left over, that's what you put into a fraction. So how many times does a 3 fit into the 10? Okay, if you can't think of the number, just think of your multiples. 3, 6, 9, 12. 12 is too big. 9 is perfect. So, well, not perfect, but it doesn't go over. So I'm going to use that. So that means that it goes in 3 times, right? 3 times 3 is equal to 9. I'm going to subtract that. 10 minus 9 is equal to 1. So I have 1 left over, and that will go over whatever I'm dividing it by, which is 3. That will be my denominator. So when I write it as a mixed number, it's 3 and 1/3. And that is the answer. 3 and 1/3. All right. Hopefully you get it. I'm trying to get more time during Zoom so that we can practice more.